The smallest planet in our solar system, Mercury, was thought to be unreachable by spacecraft for a long time. It wasn't until the 1980s that an engineer came up with the critical idea that allowed a probe to reach Mercury, and in 2011 Messenger arrived there. But what did we find there, and why was it impossible to send a probe to this planet for so long? We explain and show you the most exciting discoveries surrounding Mercury and why the planet could meet an untimely end. Keep checking back and come along as we explore Mercury together and unearth its secrets. Mercury was not further investigated for decades following the initial flybys by the Mariner 10 missions in 1974 and 1975, despite Mercury's close vicinity to Earth. This was mostly due to the tremendous difficulties of launching a probe into Mercury's orbit in the first place. Any probe launched to the planet will be driven into violent spins by the Sun's high gravitational attraction due to its close proximity to the Sun. If you will, Mercury has the most uncomfortable position in the solar system because it is so close to the blazing hot star. In addition to being exposed to unusual temperatures and strong winds, Mercury's gravitational pull causes it to tilt slightly, squeezing the smallest official planet of the solar system at its poles. Scientists had determined that the best way to solve this problem was to slow down a probe before the Sun's gravitational pull grasps it. Once in this position, the object would need to be skillfully steered into Mercury's gravitational pull in order to be bound to the planet and safe from the Sun. For a considerable amount of time, at least in terms of gravity, this accomplishment appeared unachievable. NASA engineers calculated and calculated, but the same issue consistently surfaced. The fuel needed for this maneuver would have made the probe too heavy for the other maneuvers and driven the mission's cost to unimaginable heights. Lengthy duration. The scientific community had come to the conclusion that a Mercury probe was simply impractical until the exceptionally talented orbital mechanics expert Chen Wang-Yen entered the picture in the 1980s. Rather than creating new, complex technology, she suggested a unique path that a probe could take to naturally slow down its speed and then swing into Mercury's orbit in a fuel-efficient manner. Instead of traveling directly to Mercury, the probe would have to take a longer, more complicated route. There was a viable solution to finally send a probe to Mercury. The amount of fuel required for the longer flight was so favorable to previous calculations that NASA immediately accepted Chen Wang-Yan's idea. The Sun passing other planets several times. More specifically, calculations showed that the probe would have orbited the Sun about 15 times past Earth once, Venus twice, and Mercury 3 times before finally slowing down enough to enter Mercury's orbit. The mission's theme was finally solving the mysteries surrounding Mercury that had persisted since the Mariner 10 missions. The Mariner probes were part of a NASA program to explore the solar system's Earth-like planets, particularly Mercury, Venus, and Mars. Messenger went on its journey, eventually leading to the development of the Messenger mission. Messenger stands for Mercury Surface Space Environment Geochemistry and Ranging. Launched on November 3, 1973, Mariner 10 was specifically designed to fly closer to Mercury than any other human object has ever done. It completed 3 flybys of the planet, the first on March 29, 1974, the second on September 21, 1974, and the third on March 16, 1975. While Mariner was already producing amazing new knowledge, many questions remained. In the 1960s and 1970s, scientists' curiosity about Mercury was almost unquenchable. The entrepreneurial spirit was strong, and NASA received enormous sums of money from the U.S. government. Mercury's surface could only be partially mapped during these flybys, and Mariner 10 was able to learn preliminary details about surface features, the magnetic field, and the atmosphere. Also, Mariner 10 noted that Mercury, like Venus, is the only planet in the system that does not have a moon. Despite the brilliant idea and excellent planning, getting Messenger to Mercury wasn't easy. After a journey that took several years and covered billions of miles through the solar system, the spacecraft had to perform several gravity assist maneuvers and maintain the right speed and course at all times. Messenger was able to take more measurements than ever before. The surface was to be remapped, and scientists were desperate to learn more about the planet's thin exosphere. 2011 saw Messenger enter Mercury's orbit with success. There was a lot of applause when Messenger entered orbit, making it the first probe to ever circle the planet closest to the Sun. With the beginning of the mission on the ground, NASA had accomplished another technological masterpiece, Messenger. Despite the numerous challenges that Mercury presented to science, one woman was able to find a solution. Mariner 10 had only flown past Mercury at such a distance that the measurement results were only moderately reliable. From the technicians and engineers who built the probe to the navigation specialists who launched it into space and then successfully guided it on its lengthy voyage toward the Sun and Mercury, thousands of people worked on the project for nearly 3 decades after it was completed. What did the Messenger turn up? Mission has greatly expanded our understanding of Mercury and provided a wealth of new information about the planet closest to the Sun. Among the most remarkable results of the mission was certainly the discovery of water ice in the permanently shadowed craters at the planet's North Pole. This discovery was truly a surprise, as frozen water on a planet where surface temperatures are extremely high was akin to a sensation. The presence of ice suggests that there are areas on the planet that do not receive sunlight and are cold enough to hold water in solid form. This naturally raised the question of whether liquid water could exist in marginal areas with temperate climates, or even whether simple life forms such as microbes could exist there so far. Despite the Messenger mission, neither one nor the other has been proven. However, experts believe that the violent particle storms arriving on Mercury from the Sun make even simple life impossible. We can't be quite sure about that, though, because we know from Earth that bacteria can survive and adapt here, even in the most extreme environments. Another exciting confirmation was the measurement of Mercury's magnetosphere. Mercury's protective magnetic field has only about 1.1% of the strength of our magnetic field. The job of the magnetic field is, among other things, to protect the Earth from solar winds. Since Mercury has very little protection, this speaks for a very high particle radiation on the planet. Although the magnetosphere is very weak, it was an unexpected result because until Messenger arrived, it was always assumed that small planets like Mercury could not have permanent magnetic fields. Messenger also conducted a thorough analysis of Mercury's tiny exosphere, discovering that solar wind meteorite. Computer simulations and weight and mass model calculations should help to explain why Mercury's extremely inclined orbit is revealed to be so monstrous. Because of its small size and mass, Mercury appears to be under immense pressure from Jupiter, which may have resulted from a previous power struggle between the two planets early in the solar system, which ultimately pushed Mercury into its current eccentric orbit. Speculation and models indicate that Jupiter's continued gravitational influence over billions of years could further alter Mercury's orbit. Some of these models suggest that Jupiter could eventually perturb Mercury so much that it's ejected from its current orbit in extreme scenarios. This could cause Mercury to crash directly into the Sun or even collide with another planet, possibly Venus or Earth. However, it's important to emphasize that such scenarios, although supported by mathematical models and computer simulations, are still purely speculative in nature. The exact future orbital motions of Mercury and its interactions with other bodies in the solar system are extremely complex and influenced by a variety of factors. So at the moment, we don't have to be afraid that Mercury will blow up in our faces soon. We bid you farewell today with this view of Mercury's Earth as Messenger saw it during its mission. Now tell us what you think about Mercury. What did you know about this planet so far, and which new facts surprised you the most?